send you all these notes that I made for you guys right after. All right, so CDFs and PDFs. Okay, so what we've got is, in this case, we've got the continuous random variable x, which has a probability density function, f of x being kx, 1 minus x, as long as x is between 0 and 1. So it's some sort of parabola with k unknown, as long as it's between x being 0 to 1. And then any other x value, it would be 0, and this is always the case. Maybe that's something we've got to emphasize. This would always be the case. So it says sketch the graph of y equals f of x. So sketch this graph. Well, the way you would think about it is you would ignore the x, and you would think, like the k, sorry, and you would think about what kind of graph f of x equals x 1 minus x is. Right, that would be a parabola, a sad parabola, because it's 1 minus x. So it's, when you expand this, it's x minus x squared. So it's a sad parabola, intercepts at 0 and positive 1. Between x is 0 and 1. So there it is. And then your f of x is 0, so it's going to be 0 otherwise. So you have to actually draw those two black lines that you can see that I've drawn at the bottom. Any questions there for that simple question? Okay, so right now we have a probability density function that looks something like this. Okay, and we know it's symmetrical, right? You gotta keep that in mind. So these are symmetrical. Well, this one is anyway, but this one in here right here is symmetrical, and that would help for certain questions. You'll see as we do them. All right, so it says determine the value of k. Determine the value of k. Well, what do we know? What do we know about the cumulative distribution function? What do we know about our CDFs? And how are they linked to our PDFs? What's the link between them? So our cumulative distribution functions, which is f of x, is the what of the probability density function? Is the integral of the probability density function, right? Is the integral of the PDF. Or in other words, f of x dx. So your cumulative distribution function, CDF, is PDF. CDF is the integral of PDF, which means PDF is the derivative of your CDF. Cool? Now what's really important is that this actually goes from, and this is something that was a little bit annoying last week where they had different limits in your books. Your CDFs are from negative infinity to infinity of your PDFs, right? So it's pretty much all of this, everything that we have to take into account. But from 0 to 1, we know it's this, otherwise it's 0. So it says determine the value of k. Now we know your CDFs, right, which is the integral of this, we know also that equals to 1, because we know the probability, we know the sum of all your probabilities, is going to equal to 1. Sum of all your probabilities from negative infinity to infinity is equal to 1. So that's what you're actually representing here. So your CDF is f of x, which is equal to the sum of all probabilities. Another way of saying that is the integral of negative infinity to infinity of your PDFs is also equal to 1. So that is the link. Okay, so what do we have? We've got, if f is a valid PDF, then negative infinity to infinity of f of x dx must equal to 1. Right, so therefore 0 to 1 of kx 1 minus x dx must equal to 1. Then we integrate and we solve for k, which gives me k equals 6. So now you know your new probability density function would look somewhat like this. 6x, 1 minus x, and then 0 otherwise, for x is between 0 and 1, and everything else. What did I write up there? Otherwise? Yeah. Okay. Any questions up to this stage? Do we fully get that? Are we going to remember that? We remember this relationship between CDF, PDF, and 1, and how it works. And obviously our limits, which are negative infinity to infinity. Any questions? Okay, mean, median, and mode. Now, mode occurs at the highest point, right? We said that. So we know definitely the mode's going to be half. To find your median, we make it equal to a half. We make this probability function f of x dx equal to a half, which essentially is the mode. To find your mean, it occurs right in the middle. So pretty much in this particular question, your mean, median, and mode, as the PDF is symmetric about x equals half, the mean, median, and mode are all actually equal to a half. Now the most important one is this next part. Use integration to find the cumulative distribution function. Make sure that you fully specify f of x for all real x. Now, it's really important to learn how to write your f of x's, these cumulative distribution functions, and how they work and whatnot, right? And that's what I'm trying to hopefully clear up today. So look, your f of x, by definition, is from, now this is what I was trying to tell you guys last week. You know, you can use t's and you can use x's. You saw me, I use x's, your textbooks are using t's up here. Or whatever, it doesn't really matter. So you're going to put f of x is equal to negative infinity all the way to x, f of t, t, d. And then everything after x is going to equal to 1. Will equal to 1 because you've already got your maximum probabilities. You've already summed up all your probabilities. So you'll see this in a second, right? So don't forget how this looks like. F of t dt. F of t is this function, right? You're going from negative infinity all the way to any x value, which is what you want to find here. Right, and then don't forget your cumulative distribution function, this one here, when we did the histograms and whatnot, it's always going to be rising, right? So when you draw you're going to draw your graph, technically, it would be a rising graph, right? It's always going to be increasing, something we also spoke about last week. But that's for it to be a valid PDF as well. All right, cool. Hopefully, so you understand. By definition, we've got this. So what you'll do, the correct way of doing your cumulative distribution functions is to understand that it goes from negative infinity to 0. So negative infinity to 0. Then you'll do it from 0 to technically to x, not 0 to 1. You'll do it from 0 to x. And then pretty much the rest is otherwise, and then these are all 0. Okay. Let me show you. So hopefully, with this basic example, I've cleared up every question. So let's see. So you need to worry so much about this. But thus, for f of x, your f of x equals 0 for x is less than 0. So I didn't bother doing it, but I thought you guys would already know that at the bottom here it's 0. So there it is. F of x is equal to 0 for x is less than 0, and for x being in the domain of 0 to 1, or an element of 0 to 1, f of x equals from 0 to x 6t 1 minus t dt, and that's your f of x, right? Or your f of t in this case. But I'm just going to introduce x back in. Do you guys get this line, firstly? Let's stop there. Do we understand the different formulas? Right? This one here was f of x is equal to x negative infinity f of t dt. This one here, I wrote this. Negative infinity to infinity, the sum of all of it must equal to 1. Here for my cumulative distribution function, because it's so dynamic, you can find that at any x value, you don't want to actually go to infinity. You're stopping at whatever x value you want to stop at, but you need to know where it's 0 and where it is valid and where it's again 0. Okay, so that is the formula we're going to use, not your school's one. Okay, and then we'll end up with this result. Now, do we understand why I've written, even though I've written negative infinity to x, do we understand why this becomes 0 to x? Do we really get that? Yes or no?
Is it
I don't get it.
X is an element to 0?
Say it again, Alex.
Is it because it says X is like an element to 0, like N1 or something like that? Not really.
Yeah, but I wrote that, yeah?
Yeah.
So how would you know if that's the formula? How would you know to have used it from 0 to x? So I'm saying that's the formula. Well, you don't know it's from 0 to x. What you do know is that you start from negative infinity and you're going all the way up to x. But from your graph, you know from negative infinity to 0, right? From negative infinity up to 0, it's what? It's 0. Negative infinity to 0, you are doing 0 dx, which means f of x will equal to 0 for x is less than 0. Yes? Do you get that? And then for now, the next one, so that's for that one, for that left-hand side. So let me just draw the graph here so we don't have to keep going up and down. So from this side to this side, from negative infinity to 0, now it's 0. All right, and you know why that always happens? Because you guys know that your cumulative distribution functions need to look something like this, let's say, where that must be 0 and the highest number must be 1, right? Where that's f of x. And these are, okay. So what do we got? And then from 0, yep, so it's from 0 you start because you just did all of this, that's done. Now you're up to this middle section now. And that'll be 0 to, remember you want to be dynamic because it's only true between 0 and 1. So from 0 to x, any x value, if I wanted to be here, if I want to find the probability of it being between 0 and a half, you know, whatever you wanted to find, that's what this is. That's the whole idea of your f of x. So then you integrate and you found what f of x is between 0 to 1. So it's 0 here, it's this probability here, and then pretty much anything after that, it's always going to be 1. Because the maximum probability you're going to ever have is 1. Right? So this is what your function would look like. Your function looks like this. F of x is equal to 0 if x is less than 0. F of x would equal to 3x squared take away 2x cubed as long as x is between 0 and 1. And anything that's greater than 1, your probability, your sum of all your probabilities must equal to 1. Can't go higher than that. Can we understand this?
Yes.
Yes. Steph, what about you?
Yeah. Not really.
All right, let's see questions and maybe let's see more. I don't know, but I think I did about 10 or so questions just to see how we go with these. All right. And then let me know, really, like if you still no, then we'll do it again until it has to get better and better eventually. Show that Q1, which is 0.25, right? Lies between 0.326 and 0.327. Well, now you already know what f of x is. F of x is already this. So you're just going to sub it in. 0.326, what does it give you? It gives you 0.2495. And then at 0.327, sub it in, you get a probability of 0.2509. So Q1 lies there. Now, try to remember, how did we find quartiles? Right? How did we find our quartiles? How did we find our medians? Didn't we find our medians by integrating? Right? And when we were integrating, what are you actually finding? So when you're integrating the function 6t, what are you actually finding, Alex? When you're saying here, let's integrate it, and that needs to equal to a half for medians. What are you actually finding when you're going, hey, let's integrate this?
Are we finding what, like halfway of the graph or something like that?
Yeah, no, not that. But when you're integrating, what are you actually finding? I'm trying to say. Yeah, you're right. With that,
aren't you? FX?
Yeah, that's what I'm trying to make you guys understand. You're actually just finding f of x. Right? You're finding this. You're just finding your cumulative distribution function again. That's why we've been like, oh, yeah, integrate, and then your limits will need to be your limits that are from 0 to x. And the reason why that happens is because of the same reason as I just proved you to find f of x. So if you're able to find f of x, if you guys can understand pretty much d, then you should be able to understand everything else. Now, we made it equal to a half. We found x. So we found x being, let's just say, you found it being 0.326, or you found x being 0.327. What I've done in this question, I've gone, okay, well, show that the quarter 0.25 lies somewhere between these two. And all you've got to do with this, instead of going and integrating and trying to find it, and blah, 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 which you can, but just there's no point of doing that. You'll just go, well, I already know what f of x is. It's this. As long as x is between 0 and 1, which it is. You sub it in, and you realize that's below 0.25. That's above 0.25. So that means your quartile, Q1, must lie somewhere in the middle of, or not in the middle, somewhere in between these two. It's obviously not in the middle exactly. All right, let's do it. Let's do it again. So don't worry, we'll get there. I'm just trying to link a whole lot of things, because I think the way your books had it, there was a lot of disparity. I'm trying to show you really doing the same thing. So let's look at another one. Okay, this question. Diagram below shows a graph of the probability density function of the random variable x. So that's already graphed for you, right? And since we're here, let's actually write what we think f of x is. Okay. If it's just like this, then technically here is 0 and here is 0. So you would say 0 otherwise. True. Here it's 0. Here it's 0, even though I haven't drawn it, but you get the idea. It would technically be 0. And it's only valid from 0 to 4. I think we agree with that. What kind of function would this be? If you really had to get it out, the only way you would probably be able to get the function out is by going, let me find this rise over run. I'm pretty sure, actually, yeah, I do have it down here. All right, we're going to come back to it, but we're going to do our rise over run and everything like that soon for it. So I might leave this and we'll come back to it. Let's just finish this bit off. Write down E of x. What does E of x stand for again?
Expected value.
Yes, which you would be finding the mean value as well.
Mu
as well. Correct. All of it. Perfect. So mu, the mean value, the expected value. Again, because it's symmetrical, right in the middle. Right? 2. Your mode is also 2 because the highest point is a half. Maximum value you look at for your mode. Not because of symmetry. You look at your maximum value. Your maximum y value is half. So therefore, your mode will also be 2. Okay. So by symmetry, E of x is equal to 2. Okay. The probability density function can be written in the following form. So I've gone from 0 to 2, sorry, I wasn't meant to rub that out. From 0 to 2, and from 2 to 4. We're not including that one, so yeah. And 0 otherwise. So from 0 to 2, it's AX. From 2 to 4, it's B minus AX. Now, you've got to obviously understand that it's already giving you, or I've already given you f of x equals AX. So what I was trying to say is you've got to find the function of this, you'll find the gradient of this, wouldn't you? And the gradient is rise is half, run is 2, rise is half, run is 2, slope to the right, hasn't moved up, hasn't moved down, it's passing the origin, so you know it's in the form of y equals to x. Right, there it is, y is equal to x. It's just that a is missing, a is your gradient, rise half, run a 2, so that should become a quarter. Do we understand that one? So that becomes y equals a quarter x. Yes. Okay. Then this one here, I gave you AX again, which I'm trying to say, because it's symmetrical to exactly this, this should still be y equals something minus a quarter. Okay, AX. What should B be? What should B be? Typo. What should B be? What should B be? What is the value of B? Remember, the value of B can be found using your y-intercept. So I mean, you don't have your y-intercept. So how are you going to find your value of B? What's an ID? Or what idea do you have of being able to solve this equation?
You make them equal each other.
Make them equal, but make them equal to each other. No, not necessarily. Okay, maybe I should write this. B minus a quarter x. So you've got this so far. All you want to find is B. What can you do? Come on. Yeah. You want to find B. So what do you want to get rid of? Just think of it like that.
You want to get rid of y
and
x.
And what do you know? Can you give me something? Give me a number.
I know that y equals a quarter x.
Y equals a quarter x. Yeah, that's true, but you don't want to do that because you want to get rid of both x and y. Give me another thing for x and y that you could say. And think basic. Don't make it too hard.
Like you can make x equals 0.
X equals 0. Definitely can't do that one.
That's y.
Can't you say that x equals 4 and y equals 0?
Yeah, that's the best one. X equals to 4, y is equal to 0. So then what do we get? We get 0 is equal to b minus a quarter times x, times 4. That becomes 1. So I think from there we can conclude b is equal to 1. You could have even subbed in x is 2, y is a half. That would have worked. And I thought that's what you were trying to say, Steph, when you said solve simultaneously, make them equal to each other. But you got to know that it's not really, you're not going to solve simultaneously. It's more about subbing in your points. And so since a is first, a is a quarter, I wrote that. And then b is equal to a half. B is equal to 1, sorry. And a is a quarter. You could